Okay, so this is a set of notes on the basics of probability distribution. Um, basically, we start with a thing that we call a random variable. And the variable x is something that can take the value of all of the possible outcomes of a procedure. So in a lot of cases, this is a set of numbers. In some cases, it is not. But it's just some placeholder for the possible outcomes of doing something. It's kind of vague, but we'll get down into this. What a probability distribution is it's a way to describe the probability of each possible outcome. So the probability distribution is a way to get the probability of x occurring for each x, for each value of x. So once I have that, I have a probability distribution. Okay, a discrete random variable, so this is a discrete random variable, is a random variable that can only take numeric values and there's either a finite number of possible x values or they're countable. Okay, so if there's a finite number of them, like if x can either be 1, 2, or 3, or like rolling a six-sided die, the only possible values for x are 1, 2, 3, 4, 5, 6. So that's a finite number. Now, countable would be something like, what is the probability that one student will come into Garrison Forest, or 2, or 3? Conceivably, we can have as many students as we want, but they're countable. You can't have like 1.7 students, okay? So it's like, what is the probability of 1, or 8, or 9? That would be countable. Either one of those would be an example of a discrete random variable. Okay, these are the easy ones to deal with, and those are where we're going to start. And then you have continuous random variables. And here, they're numeric values, so the random variable can only take numeric values. And the number of numeric values is an infinite, N-I-T-E, infinite, and non-countable number of values. Okay, so like thinking about this, it would be something like, what's the probability that the next person walking through the door is between 5 foot and 6 foot? Okay, see, like their heights are something that theoretically we can just keep going higher and higher and higher, and in practice there's not countable. If you give me two heights, I can always find a height in between them, so I don't have a countable number of heights. So that would be an example of a continuous random variable. Okay, so if I have a probability distribution, there's going to be certain requirements that have to be met. So we're going to get into here the requirements of a probability distribution. Okay, 1. The distribution associates each value of x with the probability of that happening. So it has to have a way to do that. Number 2, If you add them all up, the sum of the probabilities of X has to equal 1. Okay, so the total sum of all the probabilities in the probability distribution has to be 1, and each probability of X has to be between 0 and 1 inclusive. Okay, so once I've met those requirements, I have a probability distribution. So let's look at a simple probability distribution. Okay, so I'm going to create a probability distribution using a table. So if I have a discrete probability distribution, oftentimes a table is the easiest way to go here. Okay, so in my table, I'm going to have 2 births. Okay, and X is going to be the number of girls. And this will be the probability of X. So we could have 0 girls, we could have 1 girl, or we could have 2 girls. Those are the only possible outcomes. Okay, the classical probability of having 2 girls is 25%. Or no girls would be 25%. The classical probability of having 1 girl would be 50%. And the classical probability of having 2 girls is 25%, right? Because if you think about this, it's boy, 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 girl, girl, boy, girl, girl, right? 1 in 4, no girls. 2 in 4 have 1 girl. 1 in 4 has 2 girls. So this would be a probability distribution. We have the possible values for X. We have the probabilities that correspond to each of those. If you add these up, you get 1, and they're all between 0 and 1. So there you go. This is the basics of probability distributions.